Okay, so this video is, I believe it's 2b of this section of this unit. So polynomial equations and factoring. It might just say poly, EQ, and fact 2b at the top of yours. It's still the same objectives from the last video. I know I rushed a little bit, so I'm going to recap a little bit of that stuff. We're going to add and subtract polynomials, which I think we've kind of done a little bit of that already. We're going to multiply larger polynomials and simplify. We're also going to have a couple special cases, so we'll talk about that. We're just going to take a little bit more time, perhaps, maybe review a little bit. And then we'll start to foreshadow what the next topic is, which will be a lot of fun. So here's where we are. There's two types of special situations when we're multiplying polynomials, or binomials in this case, actually, that we're going to talk about today. So the first is a perfect square. So you don't have this filled in, so make sure you fill in a perfect square. All right? So that's a binomial raised to the second power. So let's think about this for just a second. So here's an aside. Aside means I'm just taking a break and talking about something random for a minute, but it connects. Well, what is 3 squared? Please do not say 6. 3 squared is 3 times itself, 3 times 3, and that is 9. What is, I don't know, 7 squared? Well, that's 7 times itself, which is 49. So what do you think this squared is? Well, isn't that going to be this times itself? So isn't that basically what we're going to have to do? Whenever you see this this right here, that it's something squared, you're just going to have to write it out twice and multiply it by itself, because that's what squared means, multiply by itself. So now you're back to plain old regular multiplying. So x times x times x is x squared. X times negative 3 is negative 3x. Okay, if these are certain things that are bothering you, you need to make sure you have those foundational skills. So when I say these things and I just say x times x is x squared, I say x times 3 is 3x, you have to know why that is and how that works. And if you don't, make sure you circle back to some exponent stuff. Okay? I think there was a video, an old algebra video, is Exponents 101. Might be helpful for you. Okay, now we got negative 3 times x. Negative 3 times x is negative 3x again. And then negative 3 times negative 3 is positive 9. Negative times a negative. Negative 3 times negative 3, positive 9. Sign errors. Watch out for those. What can be combined together? Well, coincidentally, it's usually the middle two. Negative 3 and negative 3 is negative 6. They're the same variable. They're both x's. They're the same exponent. They both have an exponent of 1, imaginary. And you cannot combine it with the x squared. So the x squared comes on down, and the positive 9 comes on down for the ride, and you are done. That's all there is to it. So I would encourage you to pause the video and try the second one, okay? Try to do that problem. I encourage you to pause it. I'm going to do it out, but maybe you want to give it a quick try. Okay, so you know it's 2x plus 4 times itself, 2x plus 4, right? Basically, we can go off of what it was on the previous, right? Just get this because this is really close and it's kind of like cluttering it a little bit. There we go. Okay. That makes me feel like I have a little more space to work. So now I'm going to multiply this times both of these things, distributing the 2x to the 2x is 4x squared. 2x times 2x is 4x squared. 2x times 4 is 8x. 4 times 2x is 8x. And 4 times 4 is 16. Think about what can be combined together. It coincidentally is usually the same, it's always the middle, right? But that's not like, you can't just go on that, but it's very typical that these kind of come out that way. So that's 16x, 8 and 8. Oops. And then the regular 16 doesn't have anything to combine with, and the 4x squared does not have anything to combine with, and that is how you do these types of problems. Box it, that's your answer. So the next one here that you want to fill in, make sure you fill in the blanks, is the difference of squares, okay? So let's just kind of take a quick look at that. Do I have a highlighter here? I guess not. Nope. Okay, so make sure you fill in the difference of squares, okay? That's in your blank. We'll have some interesting cancellation when we multiply it out. So there's going to be some cancellation going on here. So let's just go ahead and try this. X times x is x squared. X times negative 3 is negative 3x. So that's done. Now we will grab blue and we will do the bottom distributive. 3 times x is positive 3x. 3 times negative 3 is negative 9. And now we look at these being combined together. But what is negative 3x plus 3x? I mean, you know that that cancels out. That's gone. So all that's left is this x squared from the beginning. He's coming down. And the negative 9 from the beginning. He's coming down, right? He goes here, actually. And that is our final answer. So it looks a little different because they canceled each other out. They went to 0. Because negative 3x plus positive 3x is 0x. Nothing, really. Okay, pause the video, try the next one if you are ready. If not, I will do it for you. Okay. That's 9x squared plus 12x. That's negative 12x minus 16. So what do you notice? These guys should be combined together, but they cancel out. So we're left with only 9x squared minus 16 as our answer. I didn't stick to my color coding, but that's what you need to understand, okay? That's what happens. So let's go on to the next page and think about what we always remember. You can only combine like terms. I think I meant to like kind of emphasize that. You can only combine terms that are similar, like terms. That means the terms have to have the... I'm kind of beating this like a... beat a dead horse, is that how they say it? Yeah. I'm beating this to death. And that means the terms have to have the same variable. By the way, it could be the same variables and the same exponent. And now that I've said that enough, it could be the same exponents. So if everything matches up for variables and exponents, then you could add and subtract them together. CLT, combine like terms. You try these three, pause the video, give them a shot, try them now. I did put a little bit of a challenge maybe for you here on number 3. Number 1's a little tricky. Number 2 should be a pretty straightforward one. Okay, so take a moment, give those a shot, and I am going to go on to the next page. Okay, and who doesn't like a good meme just to break things up? I found this one to be pretty funny. I built this with my bare hands. And you can see he has his hands out there on the table. And he's got a pretty funny expression here. Love that one. Built this with my bare hands. Sorry, excuse me. Coughing in your ear there. Okay, so on to the next one. So you're flipping the page over. I broke it up a little bit for you. And this is really just kind of like riddles. And anything up until that line I'm going to do for you. So what I'm saying is I say what numbers will multiply to 12 but add to 7. We're foreshadowing something that's going to be really important. This skill, this like riddle solving, I guess you could say, gonna matter a lot for a long time. But I mean what two numbers, okay? What two numbers will multiply to 12 but add to 7? So obviously we know that it could be 12 times 1, it could be 6 times 2, or it could be 3 times 4. But 12 times 1, 12 and 1 add to 13. 6 times 2, 6 and 2 add to 8. But 4 times 3, they will multiply to 12 and add to 7. So what numbers will multiply to 7 but add to 8? Well, 7 only multiplies by 7 and 1. So obviously 7 times 1 is 7, and 7 plus 1 is 8. what two numbers multiply to 9 but add to 6? Well, 9 times 1 is 9, but 9 plus 1 is 10, so that's no good. So it would have to be 3 times 3. 3 times 3 is 9, and 3 plus 3 is 6. So you're going to take the same two numbers and multiply them and add them and get those numbers that I'm asking for. So why don't you try these right here? They're just it's just like a little riddle for you, okay? Everything below the black line on your paper. What numbers will multiply to 15 but add to 8? Two numbers that will do that. What two numbers will multiply to 30? Those two numbers multiply to 30, and those two numbers, those same two numbers, add to 11, and so on. Give it some thought, give it some time, and pause the video. This is the Now You Try. Okay, so if I must, I'll write it across here. Now you try. And there's usually 3 dots after Now You Try. Okay, pause the video, try it, and we are on to the next page. Not doing terribly on time, which is good. So multiplying polynomials review. Just to recap everything. The blue circles, sorry for those ugly circles on your paper, but the blue circles are going to be what you are going to do. I'm just recapping a little bit of each type. Clearly, we've done a few different types of situations here. There's different circumstances. You got to kind of problem solve, figure it out based on what's happening. And problem solving is important, you know. I mean, your phone breaks or your computer isn't working or something like that, even your car. You got to go through processes to try to figure out how to solve that problem, right? You got to say, okay, well, my computer's not working. I'm going to reboot it. My internet's not working. I'm going to unplug all the things and plug them back in. I'm going to restore Windows. I'm going to reinstall Windows. I mean, there's a lot of intense things you could do, right? If your phone's not working, a lot of you have iPhones, you hold the, you can just turn it off and on. You could try that, or you could just lock it and unlock it. Or you could press the home button and the lock button for a few seconds, and I think that helps. That usually refreshes your phone. Don't take my word on it, though, because it could delete some stuff. I don't know. Anyways, what I'm trying to say is problem solving is important. You don't always know how to solve the problem. These things that we're getting into right now, there's multiple ways to do it. There's multiple ways to solve it. There's multiple ways to get there, and you don't know what technique to use. You don't use the same technique in every situation. So that's what I'm trying to say. Anyway, sorry for the rant. Just thought it was important to say because we're getting into factoring and you're going to need to use your brain. Negative 2x squared times x squared is negative 2x to the 4th power. Positive 6x to the, well, there's a 1 here, so keep the base, add the exponents. That's positive 6 is negative 2 times negative 3. That's to the 3rd power. And then we have negative 14 because it's negative 2 times positive 7. That's a negative, not an equal sign. Try to fix that. It's not good. Sorry about that. X to the 2nd. Nothing combines because all the exponents are different. You need to have the same variable, same exponent to get there. Yes. Okay. Now you try 2, 3, 5, and 6. But if you are, now they're a little bit all over the place. So when we say now you try 2, 3, 5, and 6, I'm going to ask for questions. Okay, this is the now you try. This is not the New York Times. This is now you try. So you try 2, 3, 5, and 6. I'm going to do 4 real quick for you, which hopefully you remember because I think it's from today. We just have to multiply that thing by itself. And then we have to remember all the skills here. X times x is x squared. X times 4 is 4x. Right? 4 times x is still 4x. And 4 times 4 is 16. Now we combine the similar terms, same variable, same exponent. That's 8x. That's not 8x squared. That is not 8x squared, okay? There's a few of you that want it to be 8x squared. You think it's going to be, but it's not. You keep it the same. And that's this answer for that. So you've got 4 more to try, and I want you to ask questions on these in class. So please, you know, shout me a holler. I don't really know how you wanted me to put that. Raise your hand. Ask a question about these 4 now you tries if you're not totally clear on them. Okay, I will talk to you soon. We are out of time.